China just opened the world's largest train station, and I want to explain exactly how they built it, because when I looked into the details, I genuinely could not believe what I was reading. The station is called Chongqing East. It opened on June 27th, 2025. It took 38 months to build, 40,000 workers, 2 million cubic meters of concrete, 366,000 tons of steel. Those numbers sound big, but they only mean something once you understand what the workers were actually dealing with. The site was a mountain slope, not a flat piece of land on the edge of a city. A literal mountain slope, 20 kilometers from Chongqing city center. And before a single column could go in, before a single pile could be drilled, the entire mountain had to be cut flat. That is where this build starts. And to me, that is the part most people miss when they look at the finished station. Let me explain what cutting a mountain flat actually means. First, every meter of the slope was mapped in 3 dimensions. Every curve, every rise, every drop, measured before any machine touched the rock. Then, the machines moved in, around the clock. The rock under Chongqing is hard, not soft soil, hard rock. Some sections needed controlled explosions just to break it apart. Workers blasted the mountain, cleared the broken rock, and then blasted again. This went on for months. The confirmed result was one of the largest single-site excavations in Chinese construction history. Millions of cubic meters of rock and earth removed, all of it just to create a flat platform. But cutting the mountain flat creates 2 new problems. The cut face, the cliff-like edge you create when you slice a slope, wants to collapse back. So retaining walls had to go up along the full edge of the site, and water. Any rain that falls on the mountain above the site now runs straight down onto the platform. If water sits under a foundation, the ground softens. So drainage systems had to go in before anything else. Excavation, blasting, retaining walls, drainage, all of that before the first pile. Now the foundation. And this is where I want to slow down, because the foundation is the part nobody ever sees, but it carries everything. The ground was tested first. On a mountain site, you never assume the rock is uniform underneath. Different spots carry different loads. So engineers tested before they drilled. Then the piles went in, hundreds of them, multiple drilling rigs working at the same time. Each pile goes deep through the surface layer and into solid bedrock. Some piles reach 20 meters into the bedrock. What I find hard to picture is that you can only see about 30 centimeters of a pile above ground. The other 19 meters and 70 centimeters are completely underground, invisible, carrying everything above them. Before the concrete was poured into each pile hole, a steel cage made of rebar was lowered in. Without it, the concrete pile can only handle pushing forces, compression. With the steel cage inside, it handles both pushing and pulling. That doubles its strength. The concrete was then poured from the bottom up using a pipe called a tremie pipe. That matters because if you pour concrete from the top, the heavy aggregate sinks and the pile sets unevenly and weakly. Bottom-up pouring keeps the mix consistent. After every pile was set, It was load tested. Any failure at that stage is cheap to fix. A failure after the building is up is not. On top of the pile heads, concrete caps were added. These pile caps spread the load from a single column across multiple piles. No column sits on one pile alone. It sits on a group. Then ground beams were cast between every pile cap, connecting them all. The result is a grid. Any load anywhere on the site is shared across the entire foundation grid. That is a confirmed engineering approach for large buildings on uneven ground. And to me, understanding that made the whole foundation make sense. It is not just a lot of piles. It is one connected system. The building then rose, floor by floor. Formwork goes up. Steel rebar is tied inside. Concrete is poured. You wait for it to cure. Then you strip the formwork and repeat. 8 times, 8 full floors of concrete. And Chongqing summers are brutal. The temperature regularly reaches 40 degrees Celsius. Concrete generates its own heat as it sets. In that climate, it can crack from the inside. To stop that, cooling pipes were built into the concrete as it was poured. Cold water ran through the pipes and pulled the heat out. And each floor had to be poured in one continuous pour. If you stop halfway and the concrete starts to set, you get a cold joint, a weak line running through the floor. Trucks arrived in sequence without stopping to keep each pour continuous. The columns went up floor by floor too. The finished columns you see in the station stand 41 meters tall, but they were not built in one go. One section at a time. Rebar cage, formwork, concrete, cure, strip, repeat. Section by section, until the column reached its full height. And the finished column is not just structural. It is shaped like a tree. Like the camphor tree, which is the city tree of Chongqing. Each column branches at the top. Those branching arms connect to more points on the roof above. More connection points means better load distribution. The engineers and architects were solving 2 problems with the same object. Each column is also covered in 1,200 stainless steel scales. Every single scale is a different angle. They were fitted by hand. Workers at 5 meters, 20 meters, 35 meters up, all on the same column at the same time. The reason the scales are at different angles is deliberate. The column changes the way it looks throughout the day as the light hits different scales differently. That was a design decision. The building was designed to look alive as the sun moves. After the 8 concrete floors were done and the steel columns were standing, the roof had to go on. And this is the part that I think is the most impressive engineering problem in the whole build. The roof weighs 16,500 tons. It covers 120,000 square meters. It sits 57 meters above the ground. You cannot build something that heavy, section by section, at 57 meters in the air. The loads involved are too large. The precision required is too high. So the engineers built it on the ground instead. Sections of the roof were assembled at ground level. Every bolt was torqued to the correct specification and marked as complete. One under-torqued bolt in a 16,500-ton roof is unacceptable. After assembly, Hydraulic jacks lifted each section. Not cranes. Hydraulic jacks. Cranes could not do a direct lift to 57 meters at that weight. The jacks raised sections to column head height. Then the sections were moved horizontally along rails, slid into their final position above the station. When a section reached its correct spot, it was welded permanently to the structure. The engineers invented that specific method for this building. Lift, slide, weld. Repeat. Section by section. 120,000 square meters of roof built on the ground and moved to the sky. Once the roof was on, the glass walls went in. 1,200 tons of aluminum framing first. Then glass panels weighing 800 kilograms each, lifted individually by workers in 40-degree heat. The glass panels have expansion joints built in. In Chongqing, the glass surface reaches 60 degrees in summer and drops below zero in winter. Without expansion joints, the glass cracks as it expands and contracts. With them, the movement is absorbed silently. While all of that was happening above ground, a completely separate construction project was running below. Metro tunnels were being dug toward the site from below, at 30 meters below the concourse level. Two projects, one above ground and one underground, running at the same time inside the same building footprint. The metro connection is what makes the station work as a hub. One escalator ride takes you from the metro platforms, 30 meters underground, up to the high-speed train concourse. That connection was tunneled in, while 8 floors were being built directly above it. The tracks inside the station required millimeter-level accuracy. The station has 29 tracks. Trains run through at 350 kilometers per hour. At that speed, even a tiny error in alignment becomes a serious problem. There is no ballast under the tracks, no gravel bed. The rails are bolted directly to concrete slab. Once set, they do not move, they do not settle, and they do not need adjustment. Every meter of every track was checked with a laser before it was fixed. Then, the rails were welded into one continuous piece using thermite welding. No joints inside the station. Joints create small bumps. At 350 kilometers per hour, small bumps matter. The overhead wires, the catenary, were calibrated to the exact correct height. Too high and the train's arm loses contact with the wire. Too low and the arm damages the wire. The wire tension also changes with temperature, so the system compensates automatically. Workers calibrated it for Chongqing's full temperature range, not just one typical day. The platform screen doors had to align exactly with every train door. The train's stopping position was designed around the door locations. The floor tiles, covering 1.22 million square meters, the size of 170 football pitches, were laid by machine. Consistent spacing, identical tile after identical tile. A human crew could not achieve that consistency across that area. Then months of testing before a single passenger boarded. Every signal tested alone, then tested in combination with every other signal. No conflicting train movements could be allowed. Test trains ran at walking speed first, then at 20 times that speed under real load. After every run, a list of corrections. Fix, retest, repeat. The list had to reach 0 before opening. The snag list ran right up to the final days. Every imperfection corrected before handover. June 27th, 2025. The station opened exactly on time. 3 months after opening, it was handling 16,000 passengers per hour. That number was better than the most optimistic projections from the planning stage. Confirmed. To me, the main thing here is not just the size. Lots of buildings are large. What I find genuinely hard to process is the sequence. They started with a mountain, an actual mountain slope, and 38 months later, they had a building with 8 floors, 41-meter tree columns covered in hand-fitted steel scales, a 16,500-ton roof that was built on the ground and slid into the sky, a metro network tunneled in from below, while the floors went up above. 29 tracks laid to millimeter accuracy, and 1.2 million square meters of floor space, connecting every mode of transport in one building. And it opened on time. Most countries take longer than 38 months just to get planning permission approved. China built the world's largest train station on a mountain in that same time. And the thing that tells you the most about how it was done is this. After the last train each night, maintenance crews go onto all 29 tracks, every single night. Because a station like this, running at 350 kilometers per hour, does not get to skip maintenance. The building never stops. The work never stopped. So for me, the main thing is this. Chongqing East is not impressive because it is big. It is impressive because every single layer of it, from the bedrock piles nobody sees to the stainless steel scales everyone photographs, was solved correctly. And it was all solved in 38 months. That is how I understand Chongqing East.